take our parent graphs that we've learned now. We've done 8 of them, and we're going to look at today the vertical transformations. Okay, so what takes the graph and moves it vertically? Yeah, that was number 8. Okay, and so your quiz tomorrow is going to be all 8 of those. Now, none of this stuff with it. It's just the basic ones. Okay. Hang on, I'll be really straightforward with you. Like this. Okay. All right, that's the quiz right there. And so it's going to have all 8 of those graphs. Okay. You're going to have to graph. All right. And I'm also going to ask you here to name the symmetry. Okay. Mm-hmm. That's it. And so what I'm going to remember most here is really how do I start my T-table? Probably not. All right. Is it symmetric with the y-axis, the x-axis, the origin? Okay. All right. Now, so let's start off. And so we have an idea already about a lot of these from Algebra 2. Let's start off with this one. So say we have the absolute value of x, let's say minus 6. Okay. Now, vertical transformations, what I'm going to do is move the graph up and down, or dilate it vertically, or reflect it vertically. Okay, the thing that I'm going to remember about vertical transformations, vertical stuff happens on the outside of the function. Okay, so notice the minus 6 is outside of the absolute values. Okay, so that means it's going to affect the graph vertically. Anything on the outside of the function affects the graph vertically, and that's all we're going to talk about today is just vertical. Okay, how is it going to mess up with the graph vertically? Now, let's look at this one, and we'll start with this one since we did this one in Algebra 2. Okay, and so this is on the outside, so it's going to affect it vertically. How would it affect it vertically? Down 6. Okay, and that's called describing the transformation. So it's going to take the absolute value graph and shift it down by 6 units. Now, this is where we have to know what does the parent graph look like? What shape? It's V shape. So it's going to take the V shape and it's going to shift it down 6 units. Now, the way we do this is we don't really do it graphically, but we do it analytically because it's faster. You could graph the parent graph and then go and shift it down 6 and regraph it. Okay, but it's much quicker to go off of a T-table. So let's talk about what's our parent function that we're going to do over here. Is it x squared, x cubed? It's absolute value of x. Okay, now let's do our T-table. Now this is where we got to know. This is why I'm giving you those quizzes here. You really need to know your parent graphs and your T-table that goes with them. So what values did we choose? Yeah, -2 to +2. Okay, and I don't have to memorize this, do I? All I have to do is look at when I plug all these in. It's just if they're negative, it's going to make them into positive. That's going to be 2, 1, 0, 1, 2. And when I graph that, that gives me my V shape. Now, if I shift it down 6, remember it's vertical because it's on the outside, what would it affect over here on my T-table? The y's. Okay, so anything that's on the outside of the function is going to affect the y's because anything on the outside is vertical. So if I shift down 6, how would I do that numerically to my T-table? Subtract 6. Okay, and so this would give me what? -4, -5, -6. 1 minus 6 would be -5. 2 minus 6 would be -4. Okay, and then I'm going to graph that. All right, so now all I have to do is do my ordered pairs here. So -2, -4. And so usually the graphing part is the easy part because you've done all the work here. All right, then I got 0, 6, 0, -6. Okay, 1, -5, and then 2, -4. All right, and so is that giving me what I should look at here, a V shape? Okay, all right, and so let's notice you don't have to do this part, but the parent graph looks like this, doesn't it? And so all I did was take the parent graph and just shift it down 6 units. Okay, so when I add or subtract something to the outside part of the function, it's going to move it up or down. Okay, now let's talk about another one that's going to affect it vertically here. Okay, let's look at this example. All right, let's switch from absolute value of x. Let's do something else. Let's do, let me think just a minute. Let's do the square root of x. Right. Mm-hmm. All right, let's try this one. Let's do y equals 2 times square root of x. Okay, now this is not going to move it up 2 or down 2. Okay, because it's, what is this being done to the parent graph? It's being dilated. Right, that's a dilate. Okay, and so the idea is that it's being multiplied, right, as opposed to added or subtracted. Okay, so the way that we describe this here is this would be dilated. Okay, now we need to say vertically or horizontally because that's going to help me. Dilated vertically. All right, now why is it vertically? Because it's on the outside part of the function. Okay, outside of the function does vertically. Inside is going to go to do that horizontally. We'll do that tomorrow. So we're going to dilate it vertically by 2. Okay, now, so let's go to our t-table. Okay, now, what's our parent function? Yeah, square root of x. Okay, and so, well, we don't go from -2 to +2. This is why I got to know my parent graphs to do this. All right, non-negative perfect squares. Okay, so that would be what? 0, 1, 4, 9. And let's think about, why am I choosing these values? Well, I can't choose negatives because then I will get imaginaries. Okay, and I want to choose perfect squares so I can get nice numbers. Okay, so I don't have like decimals or something. So when we plug them in, we're going to get what? 0, 1, 2, 3. Okay, so when we dilate vertically by 2, all right, we multiply by 2 because that's what it's doing. But do I do the x's or do I do the y's? The y's. Okay, because it's vertically. And if you write down vertically here, that's going to tell you to do that instead of doing it to the x's. So this will be me. That'll still be 0. And so 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. Okay, now let's look at this graph. Okay, so all I have to do is take my ordered pairs and graph them. So you got 0, 0, right, 1, 2, 4, 4, and then 9, 6. That's way up there. Okay, so let's see what kind of general shape that we kind of describe this as. It's not a ray because it's not a straight. It's not really a line. It's like it's a curve. So it's a half of a parabola, and it's going sideways. Okay, So something like that. Okay. Now let's talk about how come it doesn't keep going. Because it's definitely going to stop there. It is not going to keep going. These numbers are what? Negative. So that would be imaginary. Okay. Another thing that I don't do is I don't reflect them. Okay. Don't reflect them. Yes. Let me just make a comparison, okay, with the last two examples that we did. So this would be outside of the function as opposed to this. That would be inside the function, okay? And like the first example that we did, okay, if I was to do one inside of the function, it would look like that. And so if it's inside of the function, it's going to be a horizontal thing. And so we're going to talk about all the horizontal stuff tomorrow. So vertical stuff today, horizontal stuff tomorrow. Now, now we've talked about what, moving it up and down by adding or subtracting something to the outside. All right, dilating, which makes it bigger or smaller. Okay, and so that's multiplying on the outside of the function. All right, the other thing is going to be reflection. Let's see if you can remember here. What's going to take maybe a graph and reflect it? A negative, okay? And a negative on the outside, okay? So let's look at this one, and let's make this one a little bit more interesting. Let's do a -2 onto it, okay? So we can make a point. Now, so this negative on the outside part of the function is going to reflect it vertically. And what I want you guys to get here is usually this is the biggest trouble are the reflections, because you have trouble imagining, does that reflect it across X or Y? Right now, I don't want you to think that way. I want you to think, does it reflect it vertically or does it reflect it horizontally? And it's going to reflect it vertically because it's outside of the function. So just to show you, what would inside of the function look like? Right, it would be parentheses. So the negative would be like this, wouldn't it? Okay? And so that's definitely on the outside part of the function. Now, and so this negative, we're going to say this, it's going to reflect vertically. Okay? Now I'm going to think about that. Would that be across the x-axis or the y-axis? Now, y'all think about it. All right? Get your hand and think about, this is a parabola, right? If I reflect it vertically, which axis would it go across? The x. Okay? And that's confusing because normally if we think vertically, we think y, doesn't it? But if it reflects vertically, okay, that's, if I take it and do this, okay, it's going to go across the x-axis. So it's going to reflect vertically, and we'll say across the x-axis. Okay, so before you say x or y-axis, say vertically or horizontally, and then think about it. If you'll think about vertically and horizontally first, then you might not miss this as much, okay? So it's going to reflect vertically across the x-axis. Now, what's the -2 going to do? Down 2, okay? So we're kind of adding a little bit more to this one. Now, let's talk about the order that this goes in, okay? When I'm talking vertically, the up or down has to go last, okay? In fact, you probably want to write that down, all right? So if you're going up / down, okay, whatever the case may be, has to be done last. Okay. Now what we're going to say tomorrow is that left right has to be done first. Okay, so if you want to go ahead and write that down, you can. Left right first, up down last. Everything else can fall in between. Okay. Now let's look at a t-table for this one. All right, what's my parent graph here? Yeah, y equals x squared. Okay, so from -2 to +2. And so how do we get these values? We just take these and square. Okay, so this would be 4, what? 1, 0, 1, and 4. All right, we start from -2 to +2, and this was the parent graph, right? So how do we get the y values? We don't have to memorize the y's. We just memorize the x. We just plug them in and get the y values. Now, so we said we're going to reflect vertically across the x-axis and down 2. Now, both of those are vertical movements, aren't they? So anything vertically is going to change the y. And so since everything is vertical today, on your t-tables on your graph, you're not going to be changing x's at all tonight, are you? Okay? No x's tonight, just the y's. Now, so let's talk about, all right, which one do I need to do? Can I do down 2 and then reflect it? No, you got to reflect first, because what? Up, down has to be done last. Okay? Now, how do we reflect something across the x-axis? This is what we just got finished with. Right, you change the sign of the y's. So what? All these are just going to change to negatives. And so that's why we learn those symmetry rules. They make sense, right? We take an ordered pair, reflect it across the x-axis, you change the sign of the y. Okay? Now, down 2, so that means I'm going to take these y values and do what to them here? Subtract 2. Okay, so now this would turn into -6, -3, -2, -3, -6. Okay, and then we're going to throw it on the graph. Can't find my graph there. Okay, so -2, -6. And we should know that what that's going to look like from experience here. We should know that that's parabola, and because it's got the negative, because it's got that negative in front of it, that means it's going to be going downwards. Okay, so by the way, what the vertex is always going to be that middle point. So perhaps not a V shape here, that's more of a U-shaped curve there.